Okay, our lesson will be graphs of polynomial functions when they are not in factored form. That means we have to factor it first. So we have seen graphs of polynomials before. The first thing we do is we have to see the degree of this polynomial. The degree of this polynomial is 3, therefore we say it's odd. And the coefficient is the coefficient of the term with the highest degree, which is positive 2. Therefore, I know that if the coefficient is positive and degree is odd, it's from here, first quadrant, to the third quadrant. Okay, so the first thing is we have to factor this so that we have x-intercepts. If this is not factored, it's easier to find always the y-intercept. Y-intercept is always, we know the last number because this is 0, 0, 0, so y-intercept is 2. To find x-intercept, I have to factor. So I have to do synthetic division. So I try the factors of 2. Let's try 1. If I substitute 1 into x, I have 2 minus 5 plus 1 plus 2, which gives me 0. Therefore, I say x minus 1 is a factor. Once I have x minus 1 as a factor, then I do synthetic division. Synthetic division, I use 1. I use the coefficients 2 minus 5, 1, and 2. I bring down 2 times 1 is 2. I add negative 3 times 1, negative 3, 1 plus negative 3, negative 2 times 1, negative 2, which I expect this one to be 0. I add 0. So this will be 2x squared minus 3x minus 2, because highest degree was 3 and this will be 2. So I factor this one now. When I factor this, I use the tail ender or by inspection. By inspection, the factors of 2, which will be 2 and 1, and this will be 1 and 2. The product is negative, so one of these numbers must be negative. Therefore, this will be negative 2, so that negative 4 plus 1 is negative 3. So this will be equal to 2x plus 1 and x minus 2. Therefore, complete factors of this will be fx is equal to x minus 1 from the previous one, to x plus 1, and x minus 2. So now it's factored. Once it's factored, I see the x-intercepts. So the x-intercepts here are 1, negative 1 over 2, and 2. And we know the y-intercept was 2. Okay, I use now my graph. It's odd. X-intercept is 1, 2, negative half. Y-intercept is 2. Therefore, I have at 2, I have x minus 2. It's a linear. It comes like a linear. Then comes back, and at 1, also it's a linear. It goes to 2, and then comes down here. So this is my graph. Okay, so let's see another example, which is different concept. B, I have gx is equal to x to the power 4 plus 4x cubed minus 3x squared minus 14x minus 8. I see the term with the highest degree, so the degree is 4, which is even. And the coefficient of the term with the highest degree is 1, which is positive. Therefore, I expect my graph to go from first quadrant to the second quadrant. So the first thing I do is I factor. I factor by trial and error the factors of 8. we start with factors of 8. It can be 1 minus 1, 2 minus 2, 4 minus 4. So let's start with, we always guess what would be the best one to substitute. Let's start with g minus 1. This will be 1 minus 4 minus 3 plus 14 minus 8 minus 3 minus 6 minus 14. This will be 0. Therefore, x plus 1 is a factor. Once I have one factor, I continue doing synthetic division. Synthetic division with negative 1. Negative 1. Coefficients of the polynomial are 1, 4, negative 3, negative 14, and negative 8. I bring down 1. 1 times negative 1, negative 1. I add 3. 3 times negative 1, negative 3. I add negative 6 times negative 1 is positive 6. I add negative 8 times negative 1 is 8. I expect the last number to be 0. Therefore, since the polynomial was 4 degree, here it will be, we start with 1x cubed plus 3x squared minus 6x minus 8. Since I have at most 4 factors, 4 real factors, I expect more factors from here. I do more synthetic division. So let's see if I have g of 2. G of 2, I can substitute here or I can substitute in the original one. So this will be 8, 12, minus 12, minus 8. This will be equal to 0. Therefore, x minus 2 is a factor. I do again synthetic division. Synthetic division would be 2. The coefficients will be 1, 3, negative 6, negative 8. Bring down 1. 1 times 2 is 2. 5. 5 times 2 is 10. 4. 4 times 2 is 8. The last number should be 0. Therefore, this should be 1x squared plus 3x plus 4. Now, this is a quadratic, and I can factor quadratic, I know. The sum should be plus 3, the product should be 4. Therefore, okay, so what numbers can I have here now? X squared plus, this is 5x. 5x. Okay, so the product is 4, the sum is 4, so this should be 4 and 1. X plus 4 and x plus 1. So now it's completely factored. Completely factored means I had already x plus 1, so gx. Since I had already x plus 1, now I have another x plus 1. This will be x plus 1 square, x minus 2, and x plus 4. And I know x-intercepts now are, this is a double one, so negative 1, 2, negative 4. Okay, so and y-intercept is the last number from the original one, which is negative 8. Okay, now a graph. I sketch the graph. Okay, gx. X-intercepts are negative 1, which is double 1. This is a double. 2 and 4. The y-intercept approximately, let's take, this is y-intercept, negative 8. Okay, since it's even and starts from here, first quadrant, it ends up here. So what should we do? So -1 is squared, and okay, let's see the intercept here. So 0 is 1 square, minus 2 square is minus 2, 4 is -8, and then x plus 1 square is 2, this is -4. This is -4. So my points are -4 because of this, -1, 2, and I have -8. So I start from first quadrant here. So x minus 2 is a linear, so it comes here as linear. It goes to -8. It goes to -1. At -1, this is quadratic. Quadratic means that it bounces back, x plus 1 square. It bounces back and then comes back. X plus 4 is a linear. This is -1. Okay, so this is a graph for this one. Now this is a typical examples of sketching graphs.